Okay, in this video, we're going to look at some phase modulation in MMMAudio and then take that all the way to Polyphony. So my Python file is going to look like this, just standard MMMAudio Python file. And I'm going to be looking for ospm.mojo, which is going to be here. So in the Mojo file, we've got just importing the Mojo library or MMMAudio library, and then we have our basic struct here. So we have a world, an init, and a next function. So first thing I'm going to do is I'm going to add a carrier, and that is going to be an oscillator, and we're going to just give it default parameters. And I'm going to add also a modulator. And that is also going to be an os. So down here, I'm going to say out equals, oh, sorry, I need to say self.carrier equals os. And that needs the world, and self.mod is the same. All right. So down here, we say out equals self.carrier, since it's an oscillator, .next. And in the next function, we want to give it frequency. So we'll just for now say 100 phase offset, and phase offset is going to be mod, and the trig is going to be false. Not going to trigger it, but the os type is going to be os type dot, let's just use a sine wave, right? Os type dot sine. Sorry, equals. Doesn't know what mod is. We haven't made it yet. So let's make that. That indentation was wrong. That's what I'm doing there. So mod equals self.mod next. And we're just going to give this a frequency of 150. So we'll get a nice harmonic modulation. And yeah, that is that. So in, and I guess we can tell it the os type. Make it a sine wave. So the thing we want to control actually is the modulation, the multiplier of the modulator. If the modulator is 0, we want no modulation, and if it can go all the way up to whatever, infinity, but up to about 30 is usable values. So I'm going to add a lag for the mouse, because we're going to use the mouse. Okay, so the mod multiplier, mod mul, is going to be self.world.mouse x, because that's where we get the mouse. It's from the world. And times 32. And I'm going to lag that. So mod mul equals self.lag.next. Mod mul. Great. The mod here, we're going to take the mod, so the modulator, and it is going into the phase of the carrier. And so we're going to multiply it by mod mul. So yeah. And we're going to return out. Great, so that should make some sound. I'm going to make that quieter than full volume. Now notice when we get out to around here, it starts to get a little crunchy, but that's just that's an extreme modulation. So we can change that to 20. But what I'm also going to do is mess around with some of the interpolation stuff that Modulation can do. So the oscillator, if we choose to give it parameters, it has default parameters. So the parameters are numChan's number of channels in the oscillator. So you can have a multi-channel oscillator. The interpolation value, which is defaulting to 1, which is linear, and then the oversampling index, which is at 0. So let's mess around with that. So we'll say 1, and we could use something like quadratic interpolation. That shouldn't change too much, but you can mess around with these kinds of things. And we'll give it some oversampling. So with 0 as the oversampling index, it's not oversampling, but if you make it 1, then it's going to do 2 times oversampling. So that means that so if we're at 48K as our sample rate, and the Nyquist frequency is at 24,000 hertz, any frequency between 24,000 hertz and 48,000 hertz is going to get filtered out rather than folding over. If it's above 48,000 hertz, then it's going to fold over. So we need to add those parameters to our carrier oscillator down here. 1 interp.quad 1. So now we're using quadratic interpolation on the carrier. Let's see if that made a difference. Now, still getting some, aliasing kind of stuff going on. But something I realized down here is I don't actually want this to go times 20. I want it to be an exponential curve between 0, obviously not 0, and 20. So rather than doing times 20 here, I'm going to use linexp to go from 0. So it's a linear values between 0 and 1, which is what the mouse gives us. And then we're going to go from 0.001. You don't want it to be 0. It won't work. It'll be divided by 0 error. And 20. Okay, let's see here if that feels any different. Yeah, it feels more musical to me. Okay, great. So now we have your basic phase modulation, right? So we're using a modulator, and we're using that to control to modulate the phase of a carrier. Okay, so what I want to do is just mess around with, we can change the kind of oscillator we're using, which will get more harmonics, right? Sine wave only has the fundamentals. So if we add, instead of sine wave, use a triangle wave, band limited triangle wave. It's not a pure triangle wave. It's made up by sine waves. If we use that instead, we should be able to hear a difference. Yeah, you can hear that has more partials. So now what I want to do is I want to be able to, instead of just playing this with the mouse, I want to be able to send messages from Python over to Mojo, and to be able to trigger a sound, and I want to have an envelope. So we're going to add a bunch of things here. So first thing we're going to do is add an envelope, and we're also going to add something. Whoops, we're also going to add something called onVparams, which is an onVparams. And an onVparams is just a struct that holds the parameters of an envelope. So basically the values, so going from where to where, the times, how long it takes in seconds, the curves, the shape of the curves, and the loop and time warp. So loop, whether the envelope is going to loop, and time warp, which we can change. So you can make a single envelope with a certain shape, but then you can change how long it actually is. We're not going to do any of that. We're going to keep it pretty simple. So we need to initialize these. Env needs world. Okay, and so the env params, we can give them default values, and actually you can do that in two ways. You can either do it in the constructor here, the init, which is what we're going to do right now. So we will give it we're going to go from 0 to 1 to 0, and we will go over 2 seconds, 2 seconds. So basically it's an envelope that goes from 0 to 1 to 0 over 4 seconds, 2 up, 2 down. Great. And so in here, we're going to say env equals self.env.next. And in the env.next, we're going to give it self.env_params. There's multiple ways to do this. We can just give it env_params, which is the way we want to do it. There are multiple next functions inside of env, but if we just give it env_params, then it will just use the current values inside of env_params. And then we need to give it a trig. So trig doesn't exist. We haven't made it. But what we're going to do is we're going to trigger the sound from Python. So from the Python side of things. And in order to do that, anytime we want to send messages between Python and MMMAudio, we need to use a messenger. So we're going to add a M, which is going to be our messenger. So the messenger is the struct that basically grabs the messages that are sent from Python. And we need to tell it world. Yes, so now we've added a messenger. And the messenger gets a couple of different kinds of values, or can get a couple different kinds of messages. So to get a trigger message, which is what we want to get, we're going to say trig equals M, which is our messenger, dot notify trig. So I'm going to jump over to the MMMAudio help, which is something we should have open anyway. And we are on the messenger page. So in the help under core framework messenger. And on here, we want to receive a Boolean. Or receive a trig. So notify trig is the function. And what we do is we tell it the name of the trigger that we're going to receive. So that's the only thing we need to tell it. So we'll just call it trig. And that should work. Why is it giving me a hard time? Yeah, that should be self.m.notify trig. So what's going to happen is it's going to be looking for a trigger. So most of the time it will not be receiving a trigger. So trigger will be false. So when it's false, it's not going to do anything. When it's true, it's going to make a new envelope. It's because envelope, when it receives a trigger, starts a new envelope. Okay, so let's make sure to multiply our envelope times the signal. And so now our program isn't making any sound, right? Because it hasn't been triggered. But you can see down here at the bottom, it says added long name trig. So it's looking for the message trig. So it tells you all of the messages when it starts up, all of the messages that have been added and that it is going to be looking for. So now we can say Maudio dot send. Now there's a bunch of sends, so we can send bool, float, floats, int, string, strings, trig. And that's the one we want. So send trig, and we're just going to say trig. So this string needs to be the same here and here, right? And so now if we send this, right? So if we send it, it will trigger. It will create the envelope. So let's add some functionality to this trigger that we've sent. Notice I put it at the top of the audio block, and there's a reason for that, because we don't want to just send a trigger message. We want to send lots of different information. So one thing that we can do actually is we now have this envelope that's being created, and I can put that up here. And we can use that to modulate the modulator. So instead of using this mouse, let's get rid of this mouse, but or let's not get rid of that line. Let's get rid of this. I also got rid of that lag because we're not going to need it, because envelope is a smooth signal that has all values. So here we're going to send it env, right? So because env goes between 0 and 1, and it's going to go between 0 and maybe 20. So great. So now the envelope is going to do that. And let's add a couple other messages to receive. So what we'll receive is the frequency of the modulator and the frequency of the carrier. Var frequency of the modulator, which is a float. Var frequency of the carrier, which is a float. We'll give it a default value, and we'll give carrier a default value. But we want to be able to update those. So the way the messenger works is we can say self.m.update, and we can update the value. Let's jump over here to the help. So if we go to update, there are a bunch of different update functions, one for each kind of type. So if we say update and we give it a float as our value, then we give it a string, then it'll update a float. If we give it a Boolean as a value, then it'll update a Boolean. If we give it an int as a value, it'll update an int. If we give it a list as a value, it'll update a list. So we'll just call this, we'll say self dot frequency of the carrier and frequency of the carrier, right? So you can see here we're using the messenger. We're going to get a value that will update the carrier value, and we're sending, this is the message, the label of the message that we're sending. So self.m.update self.frequency of the modulator freq mod. Great. So now whenever we send a message that changes the frequency of the carrier, or we send a message freak care or freak mod, it will change this value. Otherwise, it will not change the value. It will stay what it was previously. So we need to use those values, self.freakMod. All right. And last thing I want to do, the last message I want to give right now is like what the maximum multiplier is. So is it going between 0 and 20 or 0 and 8 or 0 and 10? So we're just going to add one more variable here, var mod mul float 64. Maybe default of 10, and we're going to use this messenger. And that's the value we will use here. So rather than 20, we'll say self.mod mul. I have a feeling we don't want this to be exponential, but that's fine. We'll make that as a artistic decision. So great. Okay, so now when we open it up, it doesn't go. We can trigger it. Now, what I'm going to do is I'm going to send some different messages to control these values. So I'm just actually going to copy this. That's not what the code's going to look like, but we need those messages. So we're going to use something called, we're just going to say Maudio dot send float. There's a bunch of different messages you can send here. So bools, floats being a list of floats, ints, strings, and trig. And so we're going to send float, and the float value is this is going to be the string, and the value, we're going to make that a xbrand, a random exponential value, and we'll make it just between 100, maybe 80 and 400. We'll do the same. Actually, I'll just copy this. Do the same with the modulator. Oops. And we'll do the same with the mod mul, except it's obviously going to be a different set of numbers. So that will just do random number between 8 and 12 or something like that. Okay, so now we can send all of these messages at once, and I didn't actually, that makes a lot of sense. So we need to change this to mod mul. Okay, that's cool. I think it's a little aggressive, so I'm going to change this linexp here. I'm going to change this from linx to lin to make it linear, so it'll be smoother. It doesn't have that exponential curve on the mod multiplier. So I don't want the envelope to be the same every time, and so I do want it to go from 0 to 1 to 0, but I don't want it to be for a 4-second long envelope every time. I want that to be different. So we're going to do self.m.update, and we're going to send it self.env. We're going to receive env params dot times. And so we need to give that a onv times. We need to give it a string here, an index. Yeah, so this is going to receive a list, right? So even though it's the same function, update, it's actually a different version of update. And onv times needs to send a list of times. So over in the Python side, we can say Maudio dot instead of send float, we're going to send floats, and that's going to be a what did I call that? Onv times, and it's going to be an array, and we'll say random between, I don't know, 1.5 and 2.5, and random between 1.5 and 2.5. So now each envelope should have a different duration. Whoops. Each envelope should have a different duration. So you can hear that those each have different durations. So it's a cool program, makes these nice phase modulation sounds. The problem is it's not polyphonic, right? So if so each time I trigger it, it's going to re-trigger the envelope. So now we need to make it polyphonic. So the way we're going to do that is this OSPM, we're going to turn it into an object. I'm going to call it OSPM object. I mean, you could give it really whatever name you want. And it's going to do all this stuff that it does. The difference is it's not going to actually receive the messages. We're going to put that inside of our main struct. But what it is going to receive is a trigger. So we're going to send it a trigger because, and that's going to be a Boolean. It's a Boolean value of a trigger, true or false, right? So if it receives a trigger, it will start a new envelope. If the envelope is going, the envelope continues until it ends, and then it waits for the next trigger. So this is our object, and we're going to make a new struct called with our OSPM. Let's copy this. Actually, I'll copy that. So back to where we were. So we need to give it a init. And it's going to look just like that. I could have just copied that. And a next function. And yeah, also just copy that. So it's going to have a next function. It cannot have any arguments in the next function. So right now, the first thing I'm going to do is I'm just going to copy this message code and get rid of these. So we need to add these variables. So actually, we can go up here and just copy them because we've already done the work. Great. While I'm at it, I realize I'm adding the messenger because this struct is going to receive the messages and it's going to control this one. So I'm going to remove the messenger from up here. We don't need that. You can make your structs have messengers in them, and there's a whole other way to send messages directly to individual struct objects. We're not doing that right now. Okay, and in the init function, we need to initialize those. So Okay, so now we have these values inside of our main struct, and we can receive the messages to update them. What I want to do is, instead of having all this stuff inside of the main struct, what I'm going to do is I'm going to make a list of these objects. So I'm going to have a, maybe I'll call it objects is a list of ospm obj. So we're creating a list of ospm obj. What is it complaining about? Oh, sorry, I wrote that wrong. Right. So it's a list of ospm objects. So I'm going to initialize those self.objs equals, and we're going to use Python syntax for this to initialize a list of objects. So we're going to say we're going to create a ospm obj. We need to tell it the world for underscore in range. We're just going to use a 6 here, so we're going to hard code it. So this is going to make a list of 6 ospm objects, right? So we need to, what we're going to do is we're going to trigger each object. So if we get a trigger, we want to make a, we want to trigger object 0. And if we get the next trigger, we want to trigger object 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So we're just going to trigger the next object in the list every time we get a new trigger. So the easiest way to do this is to, instead of using a trigger, send an integer that is being incremented in Python. So instead of trig, well, I'm going to actually keep trig because we still want a trigger. We want a trigger whenever we receive a new integer. So I am going to make a another variable called, I guess we'll just call it index, which is an int 64. So index, and we'll give it a default value of 0, right? So it's going to start at 0. We could start it at -1 if we wanted. Well, 0 is the right number. So trig, we still want trig, but we're not sending a trig. We're going to send an integer. So we're going to call this notify update. And it's going to be self.index and index. So what does this say? This is a funky piece of syntax. So this says that we're going to be sending an integer. If we receive an integer, it will reassign that value to index, and the trigger will be true for one sample. Then the next sample trigger is false again, and it's waiting for the next trigger. We want to do certain things if we receive a trigger. So we say if trig, then, actually I'm going to do this stuff out here. So we check for the trigger. We check to update all these values. If we did receive a trigger, now we're going to say self.objs at self.index dot. So now we're going to set these values in our object. Right. So we'll do that for each of them. And now this one's going to give me a squiggle. It's going to be like, hey, that doesn't work. So what we can do is say dot copy. The reason why it's complaining is because this is a non-copyable, implicitly copyable. It should be I'll show that error again. It's going to say cannot be copied. Well, then you just have to tell it to copy. This is not something you want to be doing every sample, but since it's happening not that often, it's not that expensive. We could also just, since the only thing we're actually changing is times, we could just do this. But we still need the copy because this is a list. Okay, so we received a trigger. If we received a trigger, then we're going to update the obj object at index, and then we need to trigger that object. So we are going to say dot next, and the thing that we can tell it is the trigger, right? So we need to call the next function on all of the objects. Actually, first things first. So this is returning a value, so it's squiggly in yellow. The value is unused. Well, we need to make an out. So we need to, what we're going to do, we have is a bunch of objects, 6 of them, and we need to add up the output of all of those and send it to the speakers, right? So I'm going to say that out, I'm going to make it a SIMD of D type 2. So basically we're saying out is 0. Out needs to be a SIMD, a 2-dimensional SIMD vector, because that's what we're sending out to the system. So we're saying that out is basically 0, or in fact it is 0, 0. The reason we're using that is because this function up here also returns a 2-channel SIMD, because we're going to say that out plus equals, so out is 0, then out equals the output of this value in the objects list. So the only one that has a trigger that is true is going to be the self.index. All the other ones need to be false. So what we're going to do is call the next function on all the other objects, but with a false. So I am going to make a for loop for I in range 1, 6. I'll show you why I'm doing that. And index equals self.index, that number that we just received, plus I mod 6. So what does that mean? So if the index is 0, then we're going to tell the 0th element to have a trigger of true, get the next value with a trigger of true, and then 1, 2, 3, 4, 5, we're going to say self out plus equals self.objs at idx dot next false, right? And then if there is no trigger, we're just going to simply call the next function on all of them. We don't need the mod 6 here. In fact, we just need the I. Return out. So yeah, so we look for a trigger. We are always updating the values. We say, okay, out is 0. If we did get a trigger, we want to look at the index of the number that we received. We want to update all the values in the object up here. Then we want to call the next function on that one object that we just updated and give it a trigger of true. So that's going to trigger the envelope, and it will make a new sound with all the new values that have just been assigned to the object. We have to call the next function on all 6 of the objects that we've made, because one of them might still be making sound, right? Like it might not be being triggered, but it could be in the middle of making a sound. The envelope might not have ended yet. So we call the next function on all the other ones with a false here, with no trigger. If we didn't receive a trigger, which is most of the time, then we just go through all of the objects, call the next function on them, and get their value, because they might be making sound. Okay, so on this side, we're not going to send trig anymore. We're sending an int. And that int, what did I call it? I called it index. And just at first we'll just call 0. So let's see if this works. All right, if I send it this value. Now if I send it the same index every time, it's going to act like it did before. If I did something like this, something silly like this, and I run this, you could hear that those two overlapped, right? You've got to control your own polyphony here. It doesn't have infinite polyphony. It has 6 voices of polyphony. So what I will do now is I will say seek equals, now this is a idea coming from SuperCollider, a sequence of values. So we're going to make a list right. So that makes, right. So this makes a sequence of 6 values. So if we say seek.next, right, it'll count from 0 to 5 and loop. So we want to call seek.next here. Okay, so something I'm missing that I want is panning. So I'm going to add panning up here because we haven't actually done any panning. And I'm going to, in my object, in my os object, I am going to add some panning. And that's float 64. And by default, we'll say self.pan equals 0. And we're just going to use, so out is a float because the oscillator is just a single channel oscillator, and it's outputting a single channel. So I'll say out2 equals pan2. And then pan2, it's missing samples and pan, so we can say the samples are out, and then the pan is self.pan. That value is not being used. We actually want it here, and so now out2 is a 2-channel SIMD. So that's exactly what pan does. Pan takes a single channel out, and then it makes a 2-channel output with this pan value. So we want that to be triggered whenever we get a true here. So we can say if trig, then self.pan equals random float 64, random uni float 64, -1, 1. So that's going to make a random number between -1 and 1 every time we get a new trigger. So now each of these sounds should be panned left and right. Great, we make our sequence. Great, selecting this every time is a pain in the butt. So we're going to make this a function called go. And we need to give it that. So now it's a function. So we can now call the go function. But also making this, doing it myself manually is a pain. So now I'm going to schedule this. So we can, in order to schedule, we have to make the function be asynchronous. So we'll say async def. So it's an asynchronous function, and it's going to be called go. And we'll give it, this is going to be a function that waits a certain amount of time and makes a new value. So it's going to make a new sound after waiting a certain amount of time. So we'll give it like a range of times. So low time equals 0.5, high time equals 3. And an asynchronous function needs a while true, right, which is always the case. Do this stuff, but then wait a certain amount of time. Right, so now we have a function that's going to loop forever, and it's going to wait a certain amount of time. It's going to do this, then it's going to wait, and then it's going to do it again, and then it's going to wait, and then it's going to do it again. So we have our own scheduler in Maudio, so we're going to say our routine, our route is scheduler.schedule go. And maybe we can give it our own numbers, not 40, 4.0. We haven't defined the scheduler, so we have to tell it to have a scheduler. So scheduler equals Maudio dot scheduler. Now it'll work. Did I redefine this? Now when you want to stop it, route.cancel, and it'll stop the scheduled future. So I want these to be a little longer, so I'm going to make these maybe like this. Yeah. Want less time between them.